Okay, let's enforce what we've just learned about looking at how many subsets have a specific element in them. We're now going to look at our set B that has the elements A, B, C, D, and E. And we ask ourselves, how many subsets of, not A, how many subsets of B have the letter D in them? I am not going to write out all of the subsets of D. That takes a very long time, so we're going to have to use one of the two methods I've already shown us. The very first method is going to be using 2 to the power of n method. So the way it works is 2 to the power of n is just think of it like your choices. How many choices do you have if you want to compute the total number of subsets? Well, you have 5. You have 1, 2, 3, 4, 5. So the total number of subsets B has is 2 to the power of 5, which we found out was 32. Okay, well, that's when you're choosing all of them. That's when you're trying to count how many total subsets, and n you have all 5 options. Well, when we're saying how many of them have specifically a D, what you're saying is D no longer becomes a free option for you. You have to have the D. You have no way of not choosing it. So in this case, our choices aren't going to be 5, it's going to be 4. You have the choice of A, B, C, and E. So your n is in fact going to be 2 to the power of 4, which is going to be 2 times 2 is 4, times 2 is 8, times 2 is going to be 16. There are 16 subsets of B that have the letter D. Let's try the second method. So the second method uses the choose technique, and I like this one a lot more. So we say n choose k. If we want to know how many total subsets B has, that's going to be the same as saying 5 of these subsets choose 0, so however many subsets you can choose 0 out of the 5, plus how many ways out of these 5 you can choose 1 of the elements, plus how many ways out of these 5 you can choose 2 elements, like a pair of elements to be in a subset. How many out of these 5 can you choose a triplet to be in a subset? How many out of these 5 elements can you choose 4 of them to be in a subset? And how many of these 5 elements can you choose to be all together in a subset? This is how you find the total number of subsets of B using our n choose k notation. But we are curious about how many of these specifically have to have a D in them. Well, how are we going to do this? Well, notice, similarly as before, we are fixing this letter D. What does this mean? Well, I used the classroom analogy before, and I'll use it again. Imagine you have a classroom of, let's say, 9 students. I'm tired of drawing squares, so I'm just going to draw a circle instead. These are your 9 students. And let's say, originally, if you didn't care, you have 9 choices, and let's say you want to choose 2 of your students, so you would say 9 choose 2. 9 options, and you're choosing 2 of them. Makes sense, and this is how many ways you can choose 2 students out of your 9. Okay, but what if, let's say, you are always going to choose the student over here? Well, what does this mean? This is no longer a choice. It doesn't matter. Your options now for choosing 2 students goes down to 8. You have 8 students to choose from, and because you're no longer choosing 1, you're actually choosing, you're no longer choosing 2, you're actually choosing 1 student out of all of these students because you've already chosen 1. We're going to use the very same logic up here, but this time we're going to add up all the possible ways. So, we no longer have 5 options. Because D is fixed, you only have 4 options. You can choose whether D is going to be alone, whether D is going to have a partner, whether D is going to be in a triple, whether D is going to be in a quadruple, or whether D is going to be with everyone else. So what does that look like? Well, that's going to look like the following n choose k notation. It's going to be 4, because we only have 4 elements to choose from now instead of 5. We're going to say you can choose none of them. You can just say D is alone. You can say 4 choose 1 of the 4, A, B, C, or E. You can say 4 choose 2. You can choose a pair to be with D. You can say 4 choose 3. So we could say 3 of these will be with D. Or we can say 4 choose 4. All of them are going to be with the letter D. So what is this? This is like saying this is the subset D by itself. This is the subset D plus something here, right? These are all the sets that have D and something else. These are all of the subsets that have D and then 2 other elements. This up here is all the subsets that have D and then 3 other elements, and then of course all is going to be all of them. So now let's add all of these up together. What is this going to be? Well, 4 choose 0 is going to be 1. You can only choose nothing once in one way. How many ways can we partner D up with one of the other 4 elements? Well, the answer is going to be 4, right? You can have D with A, D with B, D with C, or D with E. Plus, of course, you can write out the formulas 4 factorial over 1 factorial over 1 factorial times 4 minus 1 all factorial. And you're just going to get 4. Plus, how many ways can you pair D up with another pair? So how many ways can we have D and A and E, A and B, A and C with D, so on and so forth. So we're actually going to use the formula for this. That's the same as saying 4 factorial over 2 factorial times 4 minus 2 factorial, which is just going to be 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1, because 4 minus 2 is 2 and 2 factorial, and that's just going to be 2 factorial. We notice the 1's cancel, the 2's cancel, and this 2 can simplify this 4 to a 2, so we're getting 2 times 3 over 1, which is just going to be, in fact, 6. Yes, that's going to be 6. So we got 1 plus 4 plus 6. Okay, how many ways can we choose 3? That's going to be plus 4 factorial over 3 factorial times 4 minus 3 all factorial. 4 minus 3 factorial is just going to be 1 factorial, which is just 1, so I'm not even going to bother writing that out. So we're really asking is 4 times 3 times 2 times 1 over 3 times 2 times 1. The 1's cancel, the 2's cancel, the 3's cancel, so we're really left with 4 over 1. So this is going to be 4 ways of having D be with 3 other elements. And then we're going to add how many ways can we have 4 choose 4? How many ways can D be with all of them? And the answer is, of course, 1 way. There's only 1 way to write all of these elements together. The order doesn't matter, so this is just going to be plus 1. What do we get? Well, we get 1 plus 4 is going to be 5, plus 6 plus 4 is going to be 10, plus 1 is going to be 1. So there's going to be 5 plus 10 plus 1, which is going to be 16, which is exactly the answer we got with our 2 to the power of n method. Again, I prefer this method because you can clearly see that, hey, you have 1 less choice than you did before, and you can choose either none of the remaining choices, 1 of the remaining choices, 2, 3, or all of them. So, fantastic. Let's solve one more problem.